Cool.
All right.
Okay, so we can start. Hello, everyone. Welcome to today's workshop about data monetization. My name is Sasha. I'm in charge of Wagon Tokyo coding bootcamps, events, and partnerships. And I'm very happy to welcome you all to today's workshop delivered by Mohamed Batran, who is a senior data scientist at Rakuten, also a research fellow at the University of Tokyo, and who is going to talk today about the different strategies, different business models about data monetization, and a lot of different things are related to the subject. I strongly encourage you to ask any question if you have about the subject to our speakers during the chat. And probably this is everything from my side. The stage is yours. Go ahead.
Awesome. Thank you. All right. Then thanks for the introduction, and also thanks for the invitation. Let me get started by introducing the topic itself. And the title of this presentation is Data Monetization Strategies and Business Models. And there is a subtitle called Guide for Businesses to Leverage the Power of Data. And it's more of a peek into data-driven products and use cases. Starting off, I want to introduce myself as a start. I have been in Japan for about 5 years now, and I studied in the University of Tokyo. I have a master's degree in research related to big data and machine learning. And I followed that by continuing the work at the university as a cooperative research fellow. And in the university, we work on analyzing telecom data. So whenever you make a phone call or record them, send a message, most companies would record this type of data, and this is a huge amount of data. So extracting value and insights from this data is very challenging and require lots of technical kind of data manipulation and handling. So as you can imagine, this type of data about where you are and at what time is very valuable for understanding the people flow or how people move from between time and location. And that was a very important indicator for COVID-19. When people move, they usually spread disease, or kind of most governments are interested in controlling the mobility of people and trying to make sure there is no like place with a lot of people at the same time. So that was the research at the University of Tokyo. And after that, at the same time, I'm working at Rakuten. I have been working for 3 years. And Rakuten is a group of 70 plus companies and producing completely different types of data. So there are e-commerce data, there are fintech, like financial data, and there are data coming from geolocation, there are data coming from completely different services and so on. So my role is working on data-driven product development. And I worked on a large-scale logistics project as a lead data scientist. And although this topic is not really about code, like actually writing the code and so on, but my work is core like technology and development. So it's about all coding, machine learning model development, and dashboard development, and so on. But I decided for this talk that there's no one have ever asked me how to create this model. It's a very challenging kind of analogy, but I don't get the question of how do I do this? But it's always a question of, we have a lot of data, but what can we do with it? And also, what can we do with it in a way that maximizes the value of data? And what kind of KPIs should we track? And the value of data itself is a bit challenging for many people. And being able to maximize the value of data is requires a lot of work, and also requires some understanding of the market and so on. So this topic is more about that. If you have data in a company, what can you do with it? And how do you visualize the big picture around data monetization, data value, and so on? So starting off, I think this is for everyone knows that more and more companies now are collecting data. Even in the most traditional sectors, they are now starting to collect data, and they are putting so much power behind data collection and automating processes and so on. So if you go to Tokyo Store, if you go to Maruitsu, if you go to any kind of traditional business, traditionally they don't collect any data, but now you can, every payment you make, the credit card company is going to record the payment, and Tokyo, or kind of the store itself, will record on the POS, point of sales. It will also record data. So when you think that way, the amount of data has actually increased dramatically from 2010 all the way to 2020. And it's expected to increase way more. So in 2010, it was 2 zettabytes. and then it jumped to 15 zettabytes in 2015, and then it went up to 64 zettabytes in 2020. And after that, it's expected to grow all the way to 181 zettabytes. So that amount of increase is substantial. It's quite big. And zettabytes means, that big number, like 10 on the power of 21 bytes. And it's a lot of data. And, more data means more opportunity. In the same sense, thinking from that perspective, now there is a very good saying says that every data has big data in its future. If it's not now, then it's going to come in the future. And every company will eventually be in the data business. No matter which business you are, you're eventually going to collect data, and you're going to find yourself with lots of data that you either need to deal with it, or you need to find a way to monetize it, or you need to understand what to do with it. So those traditional sectors, for example, real estate, transportation, logistics, advertisement, retail, energy, and entertainment, education, and more, started to collect way more data. And now this data exists. They are adding more data, but the question still exists, which is, what is the value of data? How much money can we make from that? Or what kind of use cases can we use from our data in order to make our company way more profitable and so on? So that presentation focuses on answering those types of questions. Now, I want to jump into the topic data monetization. Initially, when anyone hears the term monetization, it comes to his mind like, wow, we're going to sell our data, we're going to make money. But there are way, way more than that. It's not only about selling data, but it's more about finding out the opportunity to add kind of a dollar value next to data without selling it. So many businesses now are under pressure to increase profit or cut down cost or find additional profitable products. Especially if you work in a big company, you always see senior management, you always see middle managers are kind of under pressure to show KPIs, to track down their cost and so on. So that kind of fact exists. And the extent of how much data can be directly or indirectly contribute to business is not really clear. Everyone in his sector is focusing on the direct revenue coming from his major kind of work. If you're in real estate, you tend to focus on real estate. And if you don't have capacity to do data science or data analytics, you just tend to delay that and so on. And identifying business models and use cases is very difficult for many people, because you might know your industry, but you might not really know every single industry that may use your data. So data monetization as a terminology is about generating measurable economic benefit from available data sources. And again, as I just showed you before, that the data size is exponentially increased. Many companies realize that the value of this data also is exponentially increasing. And the global data monetization market, the market itself, is expected to grow from 45 billion US dollar in 2018 to 371 billion in 2023. So that means more and more businesses and more companies are going to spend directly or indirectly on this type of market, which leaves a very good opportunity for those who understand what exactly is the extent to start tapping into that market. And there is also a very good quote is, in digital economy, data and information, the information you produce are among the company's most important assets. So obviously everyone knows that Facebook or Google and those types of companies, their value, of course, is a service they offer. But what make most of companies are really strong is the data they hold and the amount of understanding and impact they can make by kind of understanding the data itself. So having said that, I want to share what kind of challenges that is stand between value and also between data. So obviously, to gain some tangible impact or tangible kind of value from your data, you want to do some of the following. For example, you want to cut down cost. Your operation expense is quite high and you want to reduce the amount of cost. The second one of value is improving operational efficiency. Imagine if you have, for example, a factory, and then you have a lot of people working in those factories. But what if you can, for example, improve the efficiency of one single person so that he handles more work than he is handling now, without adding much more work at him, by just improving the efficiency from data. So for example, I worked in a project where the driver in logistics, Usually they deliver, let's say, 50 package. But if you add some optimization to use data to optimize the routes, tell them where to go, which package first, which package second, that will reduce the amount of effort and stress on them. And then they are able to deliver more than 70, 75 packages at the same exact time. So using data to directly influence the operation efficiency is one way of generating revenue. The second one is getting edge over competitors. Now the market is very challenging. There are many companies in many domains, and reach to kind of customer and understanding the customer behavior and also understand the customer need is a very challenging process. So gaining an edge over competitors by using data to understand which kind of areas we can tap in order to be more appealing to in this market is also one way. Then increasing the value, increasing your revenue, and finding strategic product line of product and gaining profit from your product is all values you can extract from data. But most companies don't really go that far in leveraging the full potential of data because there are so many challenges. And part of those challenges are understanding the different business models. And for many people, data monetization is just selling data or analyzing it to make the business more efficient. But it's a very challenging. Not many people can see the different pieces and components of the business models and how they can make money directly or indirectly. The one after that is finding most profitable use cases and products. You can always analyze data to come up with an insight, but being very generic also is not so good. So you need to target the market. If you have data about real estate or about the prices of specific, let's say, buildings, then you need to find out what kind of market that would use this data in the best way to be profitable. And the third one is securing tech talent for implementation. I think this is kind of no surprise, but the demand for data scientists and data analytics is increasing day over day. And there is a big shortage on the people that can actually implement and execute data analytics and processes. And set up computational infrastructure. Now this is becoming more and more easy with AWS and GCP and all those cloud technologies. But the one after that is data privacy and legal approvals. For many big companies, kind of just talking about data is a nightmare because of PR and because you also need to appeal as a good company. So lots of kind of challenges of what can we do and what can't we do is not easy to say without like expert in the field. So this is the full kind of picture of what is missing between different types of data and also the value that we can create. So in this one, it's hard to focus on every one of them, like how to secure talents or how to do the privacy and legal and so on. But we will focus on the first two things of the challenges, which is understanding different business models and then finding the most profitable use cases and products for your kind of data and so on. And that will, in a way or another, reach the company that have data in using it for creating value. All right. So moving on, I love this chart, and this is internal versus external data monetization. And you will see me repeating this a lot. If you have a business and that business is big enough, then you could use this data to create internal value. And internal means that the data is not going to leave your organization. It's going to stay on the organization premise. It's going to be analyzed, and it's going to create direct or indirect kind of profit from this data. While external, on the other hand, means that this data is going to be used to create money from other other markets, or it could be directly or indirectly sold to external party. Now, I'm always against selling data. Like, you cannot just take your data, just sell it to someone and just get money. In many cases, this is illegal. In many countries, you cannot do that. So there are many data products you can create and sell other than just selling the raw data itself. So this is a distinction between internal and external data monetization. And if you look at those small boxes in internal data monetization, those are some of the different small use cases you could do, like process automation, for example. I will go through another slide that go in a much wider detail about every one of them. But here is the process automation is that you want to automate a process. Now, decision-making is more and more into the non-human aspect of things. and you want to make processes to automate things. When the weather is, for example, cloudy, you want to make a specific action to, for example, like serve an ad to a specific user. So automating this process is also using data. Operation optimization, we just talked about the factory kind of thing. And we also talked about logistics. Like if you have a logistics fleet, how can you optimize the delivery in a way that minimize the amount of driver, and at the same time don't put so much stress on drivers themselves? And with that operation optimization, you can gain, you can reduce the cost, and that is a business value for you. Next is a product innovation. I haven't talked a lot about product innovation, but product innovation is when you look at the data and you understand the behavior and the pattern of purchase, or the behavior and pattern of any specific market behind the data, instantly you will find opportunities. You will see that many people are looking at that there is a trend of people that are interested in this area. So for example, for telecom companies, they are very good at doing the mobility analytics. Like they have data about mobility, and then they can understand where people move at what time of day. Of course, privacy is very good handled in that case. But then understanding that type of mobility also gives you an understanding of where people tend to spend most of their days, or where a specific audience are actually located. Or if there's a new city, people are more likely to go to that new city over that other city. And that gives you some ideas of we can launch a product for this type of segment and so on. Actually, without data, it's difficult to just come up with an idea of a product and go test the market and so on. But if you start by data in a specific market you have experience in, you just tested the market. Like you can create a product and test the market again, but you have a proof that from your data, you actually know the demand of that specific product, and you can even quantify it from what you have. Next is customer experience. Now, experience is getting more and more better, and customers, which is me and you and everyone, is becoming very busy, and there is a very big amount of, everyone is busy, and it's difficult to get attention because the information is a lot. So when you send a very small query to your company, you expect them to reply now, like on the chat or something. When you call them, you want to fix things quickly because nobody has time anymore. So customer experience is how you can kind of tap into the amount of data in order to improve the customer experience, to offer them a better service, and to customize. For example, when you look at in Netflix, you see based on your preference what kind of movies you like, and then they do a recommendation for you. And one after that is optimized sales. And one big example is, for example, like a promotion or a coupon promotion. It really depends on the person. But if I received a coupon for like something like sportwear, and I'm not really interested in sport, then that's not going to be interesting. But if I received a coupon for food and something is on sale, that for me, that's way more interesting. So optimizing sales based on data and preferences. In external data monetization, this will also, I'll go through in detail, but you have about 6 or 7 different business models that I always use in my daily work, and always have a sense of which one produces the highest value. So I will start off by talking about internal data monetization. Then I will stop for a brief. If you have any question or anything, you can feel free to ask. Now, this one is about internal, meaning that you're going to use the data internally. And the focus here is, if you want to get a keyword in that, it's the following 3 points. In data, it can be used to increase your profit, or cut down the cost, or find additional and profitable product lines. This is a general kind of usability of that. And that is a very generic line, but underneath, there are so many use cases that you can apply data for. And let's go through some of them. And one of them is improved decision making. It's also generic, but making a decision without looking at the facts is very challenging. For example, I worked in one project where if you are maintaining a telecom company, like towers, which tower you need to apply some maintenance on that tower, and you need to send a fleet to test the like signal strengths of that specific tower of the telecommunication company. And you need to do that in a manual way. Like you can just send the fleet to test here, test there. If there's a problem, fix it. But if you're measuring that with data, you're collecting data to find out the spots where the cell tower signal is not really good, then you are improving the decision-making process. You are kind of making a better decisions in allocating resources. The next one is respond to changes in the market. I think many people understand that the market is completely changing, and in one day you can find yourself selling really high, and then another day things drop. And I find it very challenging for people that like the business change, but they have no idea why. Why is our sales going down? Why is it going up? So responding to change in the market by tracking specific KPIs and finding out what's happening before it actually happens is another way for it. Spot trends. We just talked about talking about telecom and mobility data. If many people are moving in a specific place, in a specific trend, then it's likely a good idea to actually go invest in real estate in this area because it's going to go higher as the demand is increasing. And after that, gain competitive edge over your competitor, and then segment and target customers. Nobody likes to receive random emails about anything. So there is a big market about segmentation and also customer targeting. And after that is improving productivity. And then many things such as automating processes. And I really want to stop at automating processes here. There are so much manual work in this in many industries that automation can be like a very good kind of direction for businesses or direction for startups. And automation can go all the way from like making a very simple decision, such as if I receive more data, please print this report for me, and just send it to my email. This can reduce a lot of time and so on. And automation can go all the way to HR, for example. If anyone is in HR and in screening resumes and so on, it takes a lot of time to screen 100 resumes and find out which candidate is going to be interviewed, for example. But now many startups are using data accumulated in order to assess the candidates and start focusing on those candidates you want to actually interview, which kind of it's a very good use for data. And improve customer service and improve efficiencies and optimize supply chain and delivery. And in optimized supply chain and delivery, you are looking for the weakest point. You're looking for areas where you are performing the worst. You're looking for areas where you can see from data that I'm not performing very well in this area, so it's better if I start taking an action. And without really looking, it's difficult to segregate, or it's difficult to kind of say I'm doing good or bad in which area and so on. That can be, for example, in logistics. When a driver, for example, go from the depot or to deliver that package to the customer and then come back, and if there are a lot of, let's say, complaints from customers, the packages don't arrive at a good time. Now, if you are not really collecting data about the process, you have no idea which area is inefficient. Are you really putting so much packages for one driver, or it's kind of there is another problem in that? So for example, there is a case where in many cases, one driver gets assigned to a package in the very high floor, for example, like 20 floor, and you've got 50 package, and the building itself is a commercial building. So it takes so much time to go in, to open the elevator, to go all the way up, to ring the door, to give the package, to come back, to go down to the car and to drive and so on. But in other cases, one driver can deliver a package in 1 minute. If it's just in front of the street and it's a small house, just ring the door, take the package, come back. So if you're not really measuring those types of operations, it's very difficult to optimize and fine tune where you're weak and what can you improve. So optimize supply chain and delivery is kind of an important thing. And finally is innovate. And trust me, if you are a data scientist, and I hope many of you are, when you look at the data and when you start finding the very finer detail behind what's happening, you get immediate ideas of, wow, this is a big problem, and wow, the solution could be very easy. So why don't we start doing something about it? So innovation comes by actually looking and by actually asking the right questions and then debating around the solution and finally finding a good solution from the existing patents and inventions and so on. And that's area we have worked a lot on that. So our team, for example, we have submitted multiple patents just by looking at data and finding out trends and finding that, wow, there is something that can be done here. And so that's internal data monetization. And I want to focus on the next two slides. Those are for you, if you are in science or if you're in business, what kind of products that can be produced internally inside a company or organization, or even if it's a very, very small business, that we can say this is a product of the internal data monetization. And that product will be used for those kind of things, will be used for the use cases. So we have a product, we have a use case. And let me go to that. And from my experience, you've got 4 products. There may be more, but those are the like common 4 products you can derive from data. You're starting off, many businesses or many customers usually have lots of types of data. You have an on-premise database. If you have been working for long, maybe in Oracle or something, or you have an Excel file, and Excel is the best way to analyze data for many people, or you have CSVs somewhere stored, or you have data on the cloud, or you have geospatial data, or you have payment data stored somewhere, or customer data, or Google Analytics data. You've got so much data hidden everywhere, and it's not so connected. So one product of that is creating the processes and analytical that kind of work in a programmatic way, such as Python, whatever the tool is, and starting to create statistical files such as summary files. And think of this as something as simple as an Excel file. So you have, let's say, if we go back to the logistics project that I was explaining about, say you have, like you get 10,000 deliveries per day. And all those deliveries, you've got data from every single piece. You have the delivery, you have the customer data, you have the driver data, and you have the depot data and so on. But at the end of the day, you cannot look at every single one of them individually. You want to have a single Excel file that answers some KPIs for you. Like you want to know that, I want to know the average delivery time per zone, or I want to know that how many customers received their package in time, or how many of them didn't receive their package in time. Like very simple kind of analysis. So in this case, there is no need for complications. You only need to have a summary data product, which is going to be a summary file, and that will be an aggregation exported as an Excel file, or you can use something like a web interface. It could be Google Sheets, or it could be something else. And that process, a good thing about programming is it can be automated. Like if you're working in Excel, you always need to redo the same thing and so on. So the process can be automated. So every single day you wake up, you find a new Excel file to your email, you open that, and you see all the KPIs you need. It's as simple as that, and you don't really need to go through the complications of, for example, developing another product or a dashboard or reports. And that is one product. The second one is analytical report. In many cases, we're actually looking at Excel sheets is not the best way. When there are many indicators and KPIs, visualizing that is very hard, and you still need to do more work. And now it's very common to visualize things as charts, as bar chart, as pie chart, as different ways of data visualization. So instead of creating a summary file, or maybe after creating a summary file, we tend to add a process which automate the process of creating charts. So instead of only sending you an Excel file, then we will also send you a PDF report that contains most of those kind of analytics. So you can see a very beautiful, well-designed PDF about the operation for yesterday, or for the day before yesterday, and something like that. And then you can make decisions or start to track what's happening based on that report. And usually I find that important to do when the stats are complicated, and also visualization adds some simplicity layer to data itself and allow easier interpretation. And it's very common to automate the process. So instead of having for a data scientist that have to do this every single day, it's common to automate that as a process. And from that process, you receive finally a PDF report to your email. Now moving on to the second two and a more complicated kind of, so this is a dashboard. And this is one I developed like some time ago. And when you have charts, you can always create a PDF chart. But in many cases, having a PDF chart, you need to replicate many charts. For example, you want to look at the operation efficiency as a bar chart over every single day of the month, like first day, second day, third day, and so on. So the only way to do that is to create 30 bar charts. to create one chart for today, one chart for tomorrow, one chart for every single day. But it's not a very good way to kind of produce things. And if you want to look at that for 365 days, then you would want to create 365 charts, and that's only one chart. So in the cases where the definition of what you really want to look at is not clear, or it needs to be replicated across a specific parameter, then a dashboard is excellent, and it's the best way you can kind of work with your data. So for example, in this case, this is a very simple dashboard developed with Dash or Python. There are many libraries. You have Tableau, Power BI, you have Grafana if you're an engineer and just want to look at something. You have also Google Data Studio is a fantastic tool as well. But finally, you've got data, and this data is connected to a dashboard. And instead of only having a report, you have a username and password. You can log in. You can start taking a look at data from your operation, and then start to making decisions and so on. And that's the third product, which is a dashboard. Now, a more complicated product than that is a model. Wait a minute. Yeah, that one. So a model. In all those products before, what I showed you was a statistical summarization, but there is no AI and no machine learning and something like that. And AI forecasts in the future. AI do many things like thinking about what's next. For example, if you want to predict a monthly rent of a specific house, it's always hard. If I'm selling my bicycle, it's really difficult for me to know what is the best price to put this bicycle on Mercury or put it in Rakuten or to put it in a secondhand shop. And the best way is to reference to somebody else's bicycle. My friend sold his bicycle, it's close to mine, it's like that. So that's when AI comes in really handy, is creating a model where it can take a lot of data and it can make a prediction, or it can make a classification. So in many organizations, they use data to create internal models. And those models are used by businesses to quickly make a forecasting. So the process looks like this. You have a model, and then somebody can log in. Of course, you can also use that as an API, but this is an easy interpretation. You input a lot of numbers, you input a lot of things, and you click on an execute, and it go to the model, make a prediction, give you back something. And you can use that number to make a decision or to start actually using that number in something. Ideally, it's not done manually. This is a manual way, but ideally, this is done over an API where everything is automated and so on. And the value here comes from using the logistic, doing pre-processing, feature engineering, and so on. But I will skip that because we don't have so much time. So I want to go back to this, as in this is the internal data monetization kind of use cases. What can you do with data? And the way to do that is improving decision-making or competitive advantage and so on, is through using data to create those products, which is the 4 products, and then starting using them to realize the value that we talked about. And after you reach that, you can easily quantify that this model contributed to increasing the efficiency of our work by 10% or 20%. Or for example, this kind of report or this kind of dashboard enhanced our operation by cutting down time used to make a decision by 50%. This is a very usual way of reporting how your work contributes to a specific business and so on, or increase the sales of people by making a better pricing, something like that. So, there are actually very common ways to put down those kind of points. So like increasing costs and so on. So that's pretty much it for internal data monetization. And the second one I'll jump in is external. So if you have any question, please feel free to talk about it. And I start by reading the comments. So I have one is short question. Do you share your PowerPoint? Okay. Do you share your PowerPoint as a PDF at the end? Sure, if you want that. I think this actually is going to be recorded. So you could look at the recording itself, which is much better. And if you want the presentation, I can share it with you. And how do we collect data if those are out of reach? And what are the major cases if not purchasing it? So, all right, let me talk about the data collection part. So in many cases, you have a business that may be traditional and that may be a digital business. If it's a digital business and you still haven't, for example, a website, e-commerce, and you're not collecting data, then that is quite easy. You start by talking with using a service, for example, embedding Google Analytics to start collecting data about website utilization. And then you can start automating the process to kind of save that into a database and so on. And if it's a kind of a traditional business, then that needs a bit more consideration. If you are using, if you are doing the sales in a manual way, you're not recording, then this is a customizable part depending on the company. And about purchasing data, of course, the next part is external data monetization. I will talk a lot about actually what is the different pieces of data business and which one is making money in which area. So I'll talk about data purchase as well. Do data scientists think about the use cases to elevate data in the company, or it's the responsibility of the business teams? Yeah, that's a kind of a challenging point. The challenge about that is business people can always think about, what are the good opportunities, but they never know can we do it or not, because they don't know if the data you have in hand is capable of doing that. And also, from my experience, the best one to come up with an idea of what to use data for is the data scientist, the one that is actually looking at the data. And it really depends on the company. So if your role is purely technical, you're responsible for developing AI models, then that's what this company looking for. But in many roles I've seen, a data analyst or a data scientist is always responsible for coming out with the use cases by understanding the business and so on. So, and for me, it's perfect. You get to also know how your product impact things. Thank you for the clear comprehension. Could you please give some example on the data is using Rakuten internally and externally? Also, an example of how your team had improved efficiency services recently in Rakuten. Do you enjoy working in Rakuten? All right, this is a very big question. So let me start by an example. I worked in one logistics project, and the information about that is public. The presentation was done once before at the World Bank conference, so I can share with you that. And that was, using some geospatial data to track the trucks of the delivery. And in order for you to understand where the driver is on the map and start getting to know more about the delivery process. So how do we, for example, had an impact is we use this data to understand driver productivity behavior and also do optimization for the routing. If you have a 1,000 driver, and if you have, for example, think 1,000 driver and you have a 100,000 package, then you want to assign which package go to which driver. And then you want also to dynamically kind of distribute those packages if change. So that kind of area where data was very useful. And also using data to forecast the ETA, when the package will arrive to a specific customer, based on the real-time location of the specific car. And by doing that, you can predict the arrival time, and then you can send it to the customer, and that improves the customer experience. And about do you enjoy working at Rakuten, it really depends on you, and it depends on the team itself. And for me, yes, so far it has been fantastic. I am a business-driven person, and it's going well for me on that specific aspect. You get to work in technology, and also you get to work on the understanding the business and so on. Regarding the easiness of data monetization, which of those is easier to monetize, big data or small data? That's also not an easy question to answer. So if you have small data, then you can't do much with that small data. But you can easily implement the technology because you don't need a lot of investment. But if you have data that cover, the definition of big data, it covers the huge user base, meaning that you have a 100 million user data, for example, or 100 million, let's say, building data, or 100 million or 1 million, anything, but it's a big scale, then you can actually get market insights. So if you are a company that's doing that, getting the market insight can reach you there. So big data, of course, it's much more monetizable. You can get more out of it. And small data, it's much easy to handle. What are the important points when making actionable insights from the analysis? The important points is when you give a number, you always need to focus on data cleaning. You make sure that this number is representative. I think this is a big area, but in data itself, there are always representativeness. Is your data representative enough to actually say that or not? Just saying that is a big conclusion. Sometimes the data is not enough to do that. So as a scientist, your role is also to say that, wait, what I have now is not enough to give you what you need. Not only give a number, because this number is a big kind of thing. Who collected the data? And the data scientist or a team. Yeah, who collects data? So in any organization, you've got many roles. One of them is data engineering and data platform. And another one is data science. And another one is a research science. So research, focus on research and modeling. Data science, focus on connecting the data value with businesses. And data platform focuses on the engineering work that needs to actually be done to collect data from different services. So there are many kind of roles, but those are the three. All right, so that seems to what we have now. We don't have much time, so I'll go through the external data monetization. And this presentation is my experience in this business, that if now we are talking about external data monetization, meaning that you are not, you're done with improving your business, and you are now looking for opportunities where your data can be used for other people or for other markets, where you can make money indirectly, not through your services, but by offering your data to other people. And that's a very interesting part. So in this like data economy, there are 4 different types of opportunities. One of them is a business that gathers data. So if you own a website, if you are a logistics company, or if you are kind of a company, that weather company, for example, news company, you're collecting data about where the people are and so on. Then you're collecting data about people, if you're a mobile app and so on. And you are the business that generate data. And your best bet, if you have a huge user base, you can do all the next ones. If you don't have a huge user base, you can offer your data and someone else will take care of the merging it with other things. Next is data aggregators. And let me check that one. Okay. Yeah, in data aggregators, now I know like at least few companies that their job is to take data from multiple sources. Like to start, for example, connecting with all, let's say, all companies in a specific domain, all companies that offer location data, for example. Then they collect this data and they anonymize it and they deduplicate that data. And then finally, they have so much data from a specific, from many sources about the same thing. And then you are a data aggregator. Your job is not to analyze the data, you aggregate data, and then you start selling that data as a subscription or a one-time fee. And many companies are doing that now. I know few, and it really depends on the domain, but there is a huge demand in this area because not all businesses have the capacity to use the data. So someone else can come in, aggregate the data, anonymize it, deduplicate it, and start actually offering it. Of course, as it's anonymized, it doesn't really represent who is the person, but it still have a huge value. The third one is analytical and science companies. And this is very trendy now, as you don't have data, but you have a very good analytics and science capability. And the people that have data are completely different from the people that need data. For example, if you are a person that want to launch a product, you want to sell any product, you want to just, you want to know that how much people are willing to pay for that product. You don't have this data, but you also want to know that which area in Japan is going to love this product more. Well, what if you actually have this data? Well, guess what? There are other people that have this data and they don't know what to do with it. So that's when it comes to the analytical and science companies. They are very good at science. They buy data from data aggregator. They apply science, analysis, and visualization, and then they apply AI, and then they either sell you the report or sell you the service at the end of things. And then they can directly sell to the end user, or they sell to the data consultancy. Now, the data consultancy or service provider is something like a consulting firm. And in consulting firms, they might not necessarily be a high-tech company, but they are very good at communicating with customer, clients, big companies, and identifying the problem. So consulting companies usually use data to create analytics or solve business problems. They don't do so much of deep tech. And they can buy data from the previous folks, like analytical and science companies. And then they use data to create maybe data dashboards or reports, or start to consultancy is about offering a specific advice and offering a specific way to execute this advice. So I can tell you that you need to open new shops in those different cities because the demand from data is very high in those places. And this is how you do it. So they buy data from this company. which this company produces by buying data from this company, which company by doing it, and so on. So that's kind of a really big picture. If you are in this domain, you'll get to know that this is the norm now. And it's very good if you want to start a company or kind of do a business, then you need to find out which area you're going to fit in. Now, this is the best chart I have in this presentation, and which is the value over complexity of a product. I think we talked about internal data monetization. Now you have some understanding of what is a report, what is just data or summarization, what is a dashboard, and what is the API or kind of a machine learning model. And every one of them can also be used externally. So for example, let's take an example of a telecom company that is kind of having location data about user location and so on. And this is the value on impact. And also this is the complexity of how you can produce this product. And then you need to have a lot of data scientists and so on. The first and easy thing ever is to just sell your raw data. Somebody that knows, you give him a connection to a database, and then you sell the data after you deduplicate, you anonymize the data and aggregate it. And I think anonymization, think about anonymization like this. You have your phone number, you have the user ID or user demographics and something like that. And all of that is really confidential. So there is no way anyone can put his hand on. So all that needs to be completely removed. And then you might have other data that's like you kind of like dogs or something like not super confidential and so on. So this type of data, also about the house, for example, you might have the address of the house, which is quite confidential to some extent. You might have the owner and some information. You also want to remove that, but you can still use data like how many stories, how many floors, how old is it, and so on. So this is raw data service. It's the easiest way. Next is a much more complex product, but it's more profitable. It's called transformed data as a service. Now, there are many people that cannot process all this data. So instead of, as a company, instead of just selling your data, if you have some capacity, you can aggregate the data over a specific geospatial or over a specific period of time and start selling it. For example, like for telecom companies as well, one way of monetizing data is starting to say in this 1 kilometer by 1 kilometer, how many people are available every hour of the day, for example. So this is a very attractive product. It's still data, but it's like, this area, Shibuya, for example, how many people? This area, how many people, and so on. So that's a much higher product than just selling your data. Next one is data enrichment as a service. And it's not so easy to explain data enrichment, but I will have a slide next to that is what exactly is data enrichment. But just know that this is another way of using data to make money without selling your data. You're keeping your data in your company. The fourth one is customized insights report, just like what we said. And instead of just selling transformed data like this one, many people have no idea how to open the data, visualize it. They just don't like looking at numbers. They want to look at a chart or an insights report. So instead of selling them that kind of product, you can upgrade and start making reports from your data. And then people are willing in specific industry to buy that. So that's another one. Comes after that, instead of reports, you can also create analytics as a service, which is creating a dashboard and using that dashboard for people as a subscription. There is something called embedded analytics as a service, which instead of putting your dashboard for you, you can also put that dashboard for another person to put it in his website, and you collect subscription fee. Coming after that is consultation from data. And this is a bit of a high value because consultation by definition is you're offering an advice for someone. You're not just selling him something and he needs to use it or not use it and so on. But you're actually giving him an advice based on your experience and expertise in the field. So it's a bit higher value. And the last one, which is the ACE, is the best kind of product out of any data, is model as a service. You are selling an API. You are using your data to create something that people will connect to, make a prediction or forecast, and then you're keeping everything in your company. In this way, nobody ever can replicate your business model because he doesn't have access to the data, so he cannot create the model. And then it's usually the best way to sell things. Think of Google Maps, for example. When you use, for many developers, they use Google Maps API to say, how do I go from this area to that area? How much time do we use to go from Shibuya to Shinjuku, for example? Now, what you get from Google in the API response is they don't sell you the data, the raw data. They don't sell you transform data. They don't give you insights. They don't give you kind of embedded analytics. They just give you the model as a service. So they still own everything. And in that case, it's a very good way to go forward. This is another way of visualizing what I just said, but with more explanation. So I wanted to put it here. And this is, if in case you forgot, I will leave this in the video or the presentation. Now I'll talk about enrichment. This is, I think, the last slide I have, something like that. Let me check. No, I have a few more. But enrichment, yeah, if you understand enrichment, this is a very good concept. Is think of you a data scientist, who you are someone that own a business, and you have a location, something like this. 1, 2, 3, this is zip code, and you have Cairo, Doki, this is a place in Cairo, and then this is the street, for example. How much can you tell from this address? No, very little. You can tell very little by just looking at the address itself. But imagine if someone can take this address from you and can give you back so many things that identify this address itself. Like I can take this address and I can put it in the map. And instead of just giving your address, I will give you more information about that place that will make your data 10 times more valuable than your address itself. For example, I can tell you about this address that the population density in this area. By looking at the population data set, I can say that in this area, the population density is very high. So you can imagine that people living in this area can be from a specific, a very specific social demographics, or you can understand many things by understanding the population density. Next, instead of just getting the address, I can give you back the administrative boundaries of that address. Like this address is located in this area, this area, this area. Of course, you could do this manually, but if you have 1 million address, you want someone to take those 1 million address and start giving you, parsing them and say, this is in this governorate, this is in this area, and so on. Third, I can give you insights about the road network, like how far this place from the nearest road, how far it is from the highway road, how far this place is from the neighborhood, what is the nearest kind of thing to that. So that gives you more insights about the address than the address itself. After that, the places, and still you can give me the address. I'll give you back what is the nearest what is the nearest shop, what is the nearest McDonald's, what is the nearest, and so on, what is the nearest kind of cafe. And that gives you a bit of insights of, is this place attractive? Like if I want to relocate, is this a good place? We've got what is the nearest hospital and nearest school and so on. So again, you've got only one column of data, but what you can get as an enrichment is way higher. And looking at social data, a lot can be done. So that's pretty much it for data enrichment. And let me go to the next one. If you are in the external data part, you want to start doing external data. Very good point is to start by the usability of your data across industries, meaning that there are many industries out there and you want to know, first, what is the industry? And second is, what is the use case you're going to use for that industry? So for example, if you are using mobility data, those are the industries, and it can be used for COVID-19, it can be used for emergency planning, it can be used for so many things, it can be used for in advertisement, for billboard, and so on. And just by placing that, you get some context and understanding of, now it's not only we have data, now we understand which sector we can use this data for, and then we can start prioritizing this kind of usability and so on. And that's very important. So after you prioritize, you start picking something, you start doing surveys, and you get to know more. Now that one is also something we usually do, is external data product value should be mapped across industries, because you always want to start by the very high revenue and the very easy in terms of visibility. Like you don't want to create something in an industry that is not profitable in its own and they're not willing to invest, because you are externally monetizing your data. So for example, in mobility data, there are many sectors like what you see here for example, mobility data is really useful in terms of visibility. Visibility is quite okay. We could do this. And also the revenue is really high in that sector. So they're much, much likely to pay. Like advertisement, it's a crazy sector. So giving anything to kind of work on it is good. Financial services, COVID-19, government, and transportation. And you want to stay a little bit far from businesses that are low revenue, and also using the feasibility of using your data for it is quite low. Something like membership organization or construction, for example, they can still use your data, but you're going to have to work so hard to create something useful. And at the same time, it's not very profitable kind of area where you want your data to make value and so on. So If you're thinking about using data for external value and so on, this is a chart you need to do. And this one is a must to prioritize which sector you want to go after. That's pretty much it. So I think we are a little bit 2 minutes. We still have 2 minutes, so I can go very quickly over any kind of question you have. I will go to I think I have a question. Okay, I do have a question here is about privacy data handling. So just to be clear, when I talk about this, it's not really about how things work in Rakuten as a company. It's more about the industry itself, generally speaking. So not all of that is in my work and so on. So I have a question about the data privacy. How do you handle data privacy? And I think this really depends from a company to another. But in most cases, there is a very there are rules of operation for data. First, you have to identify the privacy revealing information about the specific user or a specific data as a whole, like gender, age group, kind of address, location, and so on. So these are privacy revealing information. And then you can also identify data that doesn't reveal privacy. So if you have something about that, then it's fine. So that's number one, classifying data itself as data privacy, like privacy revealing data or not. Number two is aggregation. I've worked with many projects and also in the past. In many cases, you will always aggregate data. For example, the best way to like preserve privacy is aggregate over a specific neighborhood. Say, in this area, the people that are in this area are more likely to like, for example, trips to Hokkaido. Now you are pretty fine. There is no privacy here. You are describing a specific place. This area, the people are more likely to like that kind of thing. So aggregation is also a fantastic way to preserve that. So the third one is anonymization. So anonymization means you are going to keep some data, but you're going to anonymize and really put all kind of sensitive information away. So overall, I think you do anonymization as a start, and then you start by doing aggregation. And then third one, it's not really technology, but it start like access control. It's always good idea to control who access what, even if it's aggregated data and even if it's data that's completely not so private. But in most teams and most companies, not everyone can access anything. You always have to have access rules and access rights. There are many tools to do that. And if you are interested about that, just text me after. And but just as a case, data access control is very important. And last thing on the operation part also is getting authorization about a specific use case. Even if you have aggregated data, not all use cases are ethical. So in many cases, you also want to look at, is this ethical, is not ethical, and so on, and then you start, confirming that. So that's pretty much it. I have any more question? When analyzing data, do you usually merge different kinds of data, such as actual data? Yes, exactly. Yes, I do merge a lot of data, and that's I think just working with the data you have is a big mistake in many projects. There are projects where you have enough data, but if you have data, you have a chance of making it 10 times more impactful or efficient by mixing it with data from outside, either as a free data from the government. If you are in Japan, the government of Japan have tons of data on the website of I think NFIT, something like that, about surveys, about demographics, about payment, about salaries, about everything. So if you have data, you can check that, and it's going to be very kind of useful. Now, that's pretty much it. I don't have any more question, but I will stop sharing. And if you have any comment or anything, I would love to hear that.
Thank you so much, Batran. Probably the last question, I would say, request if you would like people to get connected to you, if you want, of course, you can always share your contacts, the way you would like to be contacted if you want someone to ask you questions or connect to talk about it more. Because I feel that today was a very packed workshop, and we probably need to have one more workshop in order to elaborate on this question more.
Sure. I mean, well, I'm on LinkedIn. My name is Mohamed Batran, so you can just go there and find me, catch me on LinkedIn. I'm very active, so I'll always reply to you. And I do have one more question here, but unfortunately, I don't have time to answer it. So, Sasha, if you can record it, it's from AK. Yeah, if it's okay, I can send you the reply by email if you know who that is. That would be very good.
Cool. Thank you so much, Batran. And yeah, enjoy your evening. It was really nice to have you for the workshop. And thank you everyone for joining. Thank you for staying with us until that late. Looking forward to seeing you during our upcoming workshops. Bye-bye.
Awesome. Thanks, everyone. See you soon, hopefully. Bye.